Hi all, so once again welcome to Mathematics Mini YouTube channel. So we were solving the problems on Leibniz theorem. So let's go with the next question. So the question says like this: if y is equal to sin inverse x the whole square, then prove that 1 minus x square into yn plus 2 minus 2n plus 1 into x of yn plus 1 minus n square yn will be equal to 0. So let's start with whatever is given. So y is equal to sin inverse x the whole square. Let's take the first derivative of this one. So y1 will be is equal to 2 into sin inverse x, right? And we may have to apply the chain rule here. 2 sin inverse x we got. Now the derivative of sin inverse x, derivative of sin inverse x is 1 divided by root of 1 minus x square, right? So now I will multiply this root of 1 minus x square to the other side, so that will become root of 1 minus x square into y1 will be equal to 2 sin inverse x. Now square on both the sides, so we will get 1 minus x square into y1 square will be equal to 2 sin inverse x the whole square will become 4 sin inverse x the whole square. Okay, so if you see here 4 sin inverse x the whole square, and our y is nothing but sin inverse x square, right? So what happens? 1 minus x square into y1 square, this can be written as 4y, right? And I will take it to this side, so 4y will be equal to 0. Sin inverse x the whole square I have written as y, so 4y, this side I took, so minus 4y. Now again differentiating with respect to x, again we'll apply the product rule. First function into derivative of the second function, that is 2y1, and derivative of y1 will become y2 plus y1 square I will keep it as it is now, and derivative of 1 minus x square, 1 minus x square derivative is minus 2x minus 4 into derivative of y is y1 will be equal to 0. So this will become, so if you see here 2y1, here also 2 and y1 square is there, 1 y1 can be taken outside. From here y1 and 2 y1 can be taken. So what happens? 2 into 1 minus x square into y1 into y2 minus 2x y1 square minus, this can be written as 2 into 2y1, so 4y1 will be equal to 0. 2y1 I will take it common and I will cancel, so that becomes 1 minus x square into y2 minus x y1 minus 2 will be equal to 0. This is the required equation that we have got. Now we will apply Leibniz theorem. Now Leibniz rule we will apply. So what happens? When we apply the Leibniz rule, we will have to apply for each term in the equation. So nc0 into 1 minus x square into yn plus of 2 plus nc1 into derivative of 1 minus x square is minus 2x into yn plus of 1 plus nc2 derivative of minus 2x is minus 2 into yn, right? So the first term, if we apply the Leibniz rule, the next term, the fourth term will become 0, because we have already got the constant here. Derivative of minus 2 will become 0, so we can stop taking the derivative for the first term. So minus, so minus, what happens? I will put the minus sign here. So open the bracket here, nc0, x I will keep it as it is, x into yn plus 1 plus nc1, derivative of x is 1, so 1 into yn, okay, minus the derivative of 2, the first derivative itself will become 0, so I am ignoring that, so that will be equal to 0. So nc0 is nothing but 1, so 1 minus x square into yn plus 2 plus, see, if you see here minus is there, so I have taken minus n outside. nc1 is n, so this will become 2nx into yn plus 1, okay, plus nc2 is nothing but n into n minus 1 divided by n minus 2. I mean NCR is n factorial divided by r factorial into n minus 2 n minus r factorial. So n minus 2 in the numerator, n minus 2 in the denominator will get cancelled. So n into n minus 1 divided by 2 factorial into minus 2 is there, I am writing as it is, into yn. I will open the minus sign. So this will become minus nc0 is 1 x yn plus 1. nc1 is nothing but n, so minus n yn will be equal to 0. Okay, so on further simplification, 1 minus x square into yn plus 2. See, observe these two terms here, minus 2n into xyn plus 1 and minus xyn plus 1. So in these two terms I can take minus xyn plus 1 as common, so that will become minus 2n plus 1 into x of yn plus 1. Okay, so this 2 and this 2 can be taken cancel, but minus sign is already there, so this will become n square minus n into minus 1, so that will become n minus n square. Okay, and one more minus n is there here, so minus n. Okay, this plus, say this n is from, yeah, so this n is from this term, which is minus n square minus n, and minus n is from this term. So and this positive n and negative n can be cancelled into yn equal to 0. And further simplification we will get 1 minus x square into yn plus 2 minus 2n plus 1 into xyn of plus 1 and minus minus n square is there, so I have taken minus outside. So one positive n, negative n cancelled, so minus n square yn equal to 0, which is the required thing to be proved. Thank you for watching, and please let me know if you have any questions and queries, or on which topic you want me to make the video, and please subscribe. Thank you.